Scientists just pointed the most powerful telescope ever built at a patch of sky so small it would be hidden behind a grain of sand held at arm's length. What they found inside that tiny sliver of darkness didn't just surprise them, it broke them. Because in that one image, one single frame, James Webb counted something that doesn't fit inside any equation we have. Something that suggests the universe isn't just bigger than we thought. It suggests we may have been wrong about reality itself. And I'm going to show you exactly what they found. But I need you to stay with me until the very end of this video, because the final number, the real scale of what Webb just revealed, is something your brain is genuinely going to resist believing. It lands differently at the end, trust me. But first, quick question before we dive in. Where are you watching this right now? Drop it in the comments. Your city, your country, your couch at 2 a.m. I love seeing where these videos reach. Let's go. To understand what James Webb just revealed, we have to start with something that sounds simple. Light has a speed limit. About 186,000 miles per second. That's fast enough to circle the entire Earth 7 times in a single second. Fast enough that when you flick on a light switch, the room fills instantly, at least as far as your brain is concerned. But here's where things get strange. That speed limit means that every time you look at something far away, you're not seeing it as it is now. You're seeing it as it was, back when that light first left it. Look at the moon. You're seeing it 1.3 seconds in the past. Look at the sun, 8 minutes ago. Look at the nearest star beyond our sun. You're seeing it as it existed over 4 years ago. Now push your gaze outward, past our galaxy, past the nearest clusters of galaxies, out toward the deepest dark, and something shifts. You're not just looking across space anymore, you're looking back through time. The farther the light traveled to reach us, the older the story it tells. The night sky isn't a live feed, it's an archive, an impossibly vast one. James Webb was built to read the oldest chapters of that archive. Its mirror stretches over 21 feet and is coated in a microscopically thin layer of gold, chosen specifically because gold reflects infrared light with extraordinary precision. Webb doesn't orbit Earth. It sets nearly 1 million miles away at a gravitational sweet spot, shielded from heat, running cold enough to detect light that has been traveling for over 13 billion years. And when it finally turned that golden mirror toward the deepest, darkest regions of space, the archive cracked open. Here's what scientists expected to find when they looked at the universe's earliest era. Quiet, dim, tentative. According to our best models, the first few 100 million years after the Big Bang should have been a slow burn. Gas needed time to cool, gravity needed time to pull matter together. Stars were supposed to ignite reluctantly, one by one, in small, fragile clusters. The universe, we assumed, learned to crawl before it learned to walk. James Webb looked at that era and found galaxies already sprinting. Not faint sparks, not primitive clusters, full, massive, furiously active galaxies, blazing with star formation when the universe was less than 300 million years old, less than 3% of its current age. To put that in human terms, if the universe's entire history compressed into 1 year, these galaxies appeared on January 2nd, and they looked like they'd been there for months. Some contained hundreds of millions of solar masses worth of stars. Some already showed signatures of carbon, oxygen, nitrogen, heavy elements that only exist after generations of stars have already lived and died. Which means before these galaxies existed, there was already an earlier chapter. Stars that formed, burned through their fuel, exploded, and scattered their remains, all within a window our models said was too short for any of that to happen. Astronomers have a name for this. They call it the too much, too early problem, and it doesn't have a clean solution yet. Webb also found something else that shouldn't be there. Supermassive black holes, some weighing billions of times the mass of our sun, already fully grown when the universe was barely an infant. Building a black hole that massive should take far longer than the universe had available. The math doesn't work, and yet, there they are. But here's where it shifts from surprising to genuinely unsettling. Webb didn't just look at one corner of the sky, it looked at multiple directions, different regions, different instruments, different wavelengths, and every single time it found the same thing. The early universe was crowded, not sparse, not fragile, dense, organized, and luminous, as if the cosmos hit fast forward on a process that was supposed to take billions of years. And then Webb did something even bolder. It stared at a patch of sky roughly the size of 3 full moons placed side by side. For hundreds of hours it collected light, exposure after exposure. And when those images were combined, inside that one patch of near-empty-looking sky, Webb counted 800,000 galaxies. 800,000 galaxies in a region of space your thumbnail could cover. Each one not a star, a galaxy, each containing millions, billions, sometimes trillions of stars, many with their own planetary systems, their own chemistry, their own history. Now scale that out across the entire observable universe, and here is where we arrive at the number I promised you at the beginning, the one your brain is going to push back against, the one that changes everything. For decades, our best estimate was that the observable universe contained roughly 200 billion galaxies. That number already felt impossible, already felt like it broke language. But Webb's data, real observations, real measurements, suggests we were off. Not by a little, by a factor of 10. The true count may be closer to 2 trillion galaxies, 2,000 billion, all within the portion of the universe we can actually see. But here's the part that quietly dismantles everything. The observable universe is not the universe. The observable universe, the full 93 billion light-year sphere around us, is simply the region from which light has had time to reach us. Beyond that boundary, space doesn't stop. The universe doesn't end. There's no wall, no edge. Space simply continues. Galaxies still form out there. Stars still ignite and collapse. Black holes still merge. Entire cosmic histories unfold in regions so far away that even light, traveling since the beginning of time, will never bridge the gap. Not because it isn't fast enough, but because the space between us and those regions is expanding faster than light can cross it. Most of the universe is permanently beyond our reach. Not someday reachable with better technology, permanently unreachable, hidden by the physics of space-time itself. And this is what James Webb really revealed. Not just new galaxies, not just broken timelines, not just black holes that shouldn't exist. Webb showed us the true shape of our ignorance. It showed us that the universe is so incomprehensibly large, so populated, so structured, so active, that everything we've ever observed in the entire history of astronomy might represent something like rounding error compared to what actually exists. 2 trillion galaxies in our observable bubble alone. And beyond it, we don't know. We can't know. The universe doesn't owe us a view. What Webb gave us is this: the most detailed, most honest portrait ever painted of the cosmos we live in. And that portrait shows a universe that started faster than we thought, grew larger than we calculated, and hides more than we will ever see. If that doesn't make you feel simultaneously small and strangely alive, I don't know what will. If you made it to the end of this video, drop a star emoji in the comments. I want to see who stayed for the full reveal. And if this changed how you think about what's out there, share it with someone who needs their mind expanded today. Subscribe if you want to keep exploring. There's so much more to discover.